Welcome back, guys. This is the last lesson in our book that we're going to do this year. This is the last thing in chapter 11. I have a final lesson today about how you choose the most appropriate display for your data. All right, you've got some numbers, you've got some data, you've collected it, you want to know how to display it to make it the best and the most appropriate for your purpose. And that's what we're going to look at today. There's a couple parts to it, but I'll move through them as best as I can. First of all, we're going to get some questions today asking us what type of data do we have. There are basically two types of data. You have quantitative and qualitative. Now, I'll be honest, this is something that I was really struggling with. Even as an adult, I didn't always know what these words meant when I would read them. And so if this is a tough one for you to understand today, don't feel bad. This is kind of a fancy pants word. Look at all those syllables. Anyway, we have two types of data. Quantitative, you see I've underlined kind of the prefix here, kind of the root word. Quantitative is talking about the quantity, right? A quantity is how much you have or how many items you have. And so quantitative data is going to be data that describes how much or how many of something that you have, right? How long it took you to do something. This is all data that is going to be measurable, right? Things that you have measured. Right? You've either calculated it, you've measured it with some type of ruler or yardstick or tape measure or a stopwatch or some type of a scale, right? Things like people's heights, people's weights, that's stuff you obviously measure, how fast you are, how long it takes you to do something, right? Your test score is measured based on how many you got right and how many you got wrong, right? The amount of money that you make at a job is something that you can measure and compare it to somebody else. And so when it's numerical data, data that you are describing how many or how much of something you have, we're going to call that quantitative. And then on the other side, we have qualitative. And I underline quality, well, quality is what we're looking for here, right? Qualitative data isn't going to describe things that you can measure. It's going to put things in categories, right? It's going to be more descriptive. It's going to talk about the characteristics of something. For example, if I did a survey and I asked everyone, hey, what's your favorite brand of, pop or soda, right? If I asked you what's your favorite type of dog, or if I just wrote down everybody's jersey number on the football team, right? I can't really measure your jersey number. It's not measurable. It's just a different category, right? All the receivers get numbers that are in the 80s. All the linemen get numbers that are in the 50s and 60s and 70s. Quarterbacks get numbers between, 10 and 20, especially in the NFL, right? If I ask you who your favorite artist was, right? You see the difference? Over here, these are numbers that you have measured. You've used a stopwatch. You've measured it. There's some type of scale. Over here, it's just types and categories of information. Okay? So that's the difference. Quantitative, you're talking about the quantity, how much of something you have. And qualitative is talking about the qualities or the characteristics, the categories you would put something in. Okay? So we're going to get some questions. It's going to ask you to put some examples into one of those words. And so I did a few here. See if we can test our skills. Quantitative or qualitative. All right, number one, the lengths of songs. Okay, so the big thing you're asking yourself is this something I can measure? Is this measurable? Can I measure how long a song is? Of course I can. If you can measure it, it is quantitative, right? How long a song is. You can measure that. There's a quantity for that. The types of shoes. When I say types of shoes, maybe you've got Jordans, maybe you got Adidas, maybe you got New Balance, maybe you got, whatever, Vans. When you're talking about types of shoes, not the size, but the type of the shoe that you have, right? This is a qualitative. You're talking about the qualities. Qualitative. Hard word to spell. Now, if I was doing shoe sizes would be quantities, right? Because I can measure how big your foot is. But when I'm talking about the type of the shoes, then I'm doing the qualities. The next one, number 3, the height of your classmates. What do you guys think? If this is somebody's height, can I measure that? Of course I can. If I can measure it, quantitative is what I want to pick. How tall everyone is in inches or centimeters or whatever we're measuring it in. Zip codes. If I did a survey of people's zip codes as they walked into the mall or walked into a stadium, zip codes. Can I measure a zip code? Not really. A zip code is just kind of assigned to you. I mean, it has numbers in it, but is it really a measurement of anything? No. So things like zip codes, phone numbers, qualitative. Hang on, make sure I don't spell this one wrong. Qualitative. I spelled it wrong up here. How many T's? Qualitative. I went a little bit crazy up here. Qualitative. Sorry about that. It's one of those deals where you get talking and you don't pay attention to what you're spelling. I knew something was wrong there. Okay, so zip codes, phone numbers, jersey numbers, even though they have numbers in them, they aren't things that you can measure, right? And so those are going to be qualitative. All right, we're moving right along. Today's video is not going to be very long, guys. The next thing they're going to ask you to do is they're going to say, okay, here is some information, and they're going to ask you what is the best type of display for you to pick, right? You actually have to pick one of these options. And let me kind of scoot this back so I can fit it all on here. These are all the different types of data displays. Now, we haven't done all these in this class. You've maybe done some of these in the past in 6th grade, 7th grade, 8th grade. Maybe you've never done some of these before. Some of these I've used quite a bit, some of them I haven't. But here are some of the choices that you'll have to pick from. And on some questions, there is no one perfect answer, but as long as you're in the right kind of category, you see how some of these I put quantitative, some of them I put qualitative, some of them I put both. As long as you are kind of in the right category and you can justify what you're doing, a lot of times they'll accept answers that are in the right range here. So up first, let me actually scoot this a little bit. Well, no, this will be fine. Pictograph. I've never really done a pictograph in my life. Pictograph I feel like is more of an elementary skill where you show data using pictures, right? It's almost like a bar graph, but instead of drawing bars, you do pictures. And you say, hey, this is how, each little person represents, 5 people, or you could draw little birds, or you could draw little dollar signs for the amount of money you made at or whatever, right? It shows data using pictures. So this is going to be qualitative usually. Bar graphs are the most famous qualitative graphs. They show data in categories. Most important word right here. This is why it is qualitative, right? Because you're just showing your favorite teacher or your favorite brand or your favorite artists or something like that. This is in categories. And so that's why these bars, notice the bars do not touch in a bar graph. Very important, sometimes an overlooked skill, especially in elementary schools. Bar graph is qualitative. It has things in categories. The bars do not touch. That's the most famous qualitative data. A circle graph. Circle graph you can use for both qualitative and quantitative. A circle graph is whenever you want to put or want to demonstrate parts of a whole, right? Show what percent is in each category or in each group, right? It doesn't have to be a category. You want to show parts of a whole. A line graph is very, very famous for showing change over time. That's the most important part of a line graph. If you're going to measure something over time, right, you definitely want to use a line graph. And that will usually be quantitative data. A histogram, we just had those in, a couple lessons ago. A histogram shows the frequencies in intervals, right? This is where it's going to look like a bar graph, right? You notice the bar graph, the bars do not touch. On a histogram, the bars do touch. The reason the bars touch on a histogram is because your data are not categories. This is not like your favorite artist or your favorite brands or your favorite, types of drinks. These are going to be intervals, right? Like 0 to 5, 6 to 10, 10 to 15, 15 to 20. These are going to have intervals of numbers along the bottom. They're not going to just be categories, and that's the big difference. A stem and leaf plot kind of looks like this. A stem and leaf plot is for quantitative because it's for numbers. You can actually use a stem and leaf plot for like jersey numbers and stuff, so it could be both. But it's typically for quantitative data, and it's going to put numbers in order, and it's going to show how they're distributed, right? Or distributed, let me speak English correctly. If you want to put numbers in order, you just want to demonstrate a bunch of numbers, I do a stem and leaf plot when I collect the jerseys every year for a sport. Like, for example, football has black jerseys and white jerseys. I actually do a double stem and leaf plot, or our book calls it a back-to-back stem and leaf plot, where I'll put black jerseys on one side, white jerseys on the other side, and I'll just list all the numbers. You know, 0s, 10s, 20s, 30s, 40s, 50s, 60s, 70s, 80s, and that way I can see quickly, in a real, quick second, which jerseys are missing. So that's what a stem and leaf plot is good for. A box and whisker plot we just had not too long ago in our videos, that's for quantitative data. Sorry, it got smeared there. It shows the variability. This is going to show the variability using quartiles, right? Quartiles. So if I wanted to know what percent of my people scored between this number and this number, I would use a box and whisker plot. If I want to know the variability, right? If I wanted to say half of my people scored higher than this, or half of my numbers are lower than this, or 25% are greater than this, that's when I want to look at a box and whisker. A dot plot is kind of an elementary style thing. I don't really do that. I've never really done it much in 8th grade. It's going to show the number of times each value occurs in a list, right? So if I had a big list of numbers, how many tardies everyone has in my class this year, right? If I didn't want to do a histogram, I could also do like a dot plot and say, okay, 3, 4, 5, 6, right? And like 3 people would have 3, 1 person would have 4, 2 people would have 5, 4 people would have 6 tardies. A dot plot doesn't get used a lot once you get past elementary school, but it can be somewhat helpful in elementary. A scatter plot, you can do scatter plot for both. A scatter plot is going to try to show a relationship between two things, right? When we're trying to figure out, is there a relationship between how long you study and the grade you got on my quiz? Or is there a relationship between how tall you are and how fast you run? Is there a relationship between the temperature outside and the amount of money that Dairy Queen makes? Or something like that, right? That's what a scatter plot is for. So as long as you kind of know what each type of display is used for, that's going to help you select the correct one, depending on what your purpose is, right? So feel free to go back to this or pause the video on this slide where you can use it to help you in the questions today. All right, the very last thing. This is one of my favorite topics, and I'm sad that we didn't get to talk about it in person this year. Misleading graphs. You see misleading graphs all the time on TV, on the internet, in magazines. Misleading graphs are graphs that either on purpose or on accident, but it's usually on purpose, people make to try to make you believe something that may not be true, right? How can you make a graph misleading? You can make a graph misleading by not putting a title, not spacing your scale evenly, right? Like maybe you start out counting by 5s and then you switch to counting by 2s or counting by 20s. You can make a graph misleading by not starting at 0. Now this one starts at 0, but this one doesn't, right? You can make a scale misleading by not putting a key, like if you're doing a stem and leaf plot and you didn't put a key on it. You could not label the axes, like if here I didn't put month, and if I didn't put price off to the side, right? That would be misleading. Sorry, my handwriting's sloppy there. You could make it by the bars not all being the same size. Like if you're doing a bar graph and you made a couple bars really thick and you made one of them really skinny. But anyway, here is a classic example. These two graphs look very different, but they're actually showing you the same information, right? And so here's how you can use the idea of misleading somebody with a graph, right? If I was trying to sell something to somebody, and if I was trying to say, hey man, or please buy my stock, buy part of my company, look how much my company is making, look how much this item has gone up in value over the last couple of weeks, right? Or last couple of months. If I'm trying to sell you something, I want you to think, oh man, this is going to be really valuable. Look how this graph makes it look like this thing is shooting through the roof. Boom, 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 boom. Because look, how did they accomplish that? How did they make this line look so steep and this line look kind of flat, right? Well, you can see what they did over here, right? They did a break in the axis. They didn't start at 0, right? They have 0 right here, but then look, they skipped from 0 to 7. And when you skip from 0 to 7, you're completely deleting this whole chunk of the graph. And you're zooming in on the $7 to $10 mark. Because look, in January, it was $7.50. February, it's $8. March, $8.50. April, the price of this is $9.50. And so we've gone from $7.50 up to $9.50, right? It's really only gone up by $2. But look what this graph does. It makes this thing look like it's shooting straight off the graph, right? Look how high that thing is going. This is a graph that someone would make to make you want to believe that the price of this is just really increasing by a great amount, right? But in reality, this is misleading. This one over here is accurate. Notice we started at 0 and we counted by 5s. 5, 10, 15, 20, 25. I didn't do a break in the axis. So a break in the axis will always, always, always be misleading to people, right? This is the better way to do it, right? Do you see how this looks much more flat? If I showed this to somebody, would they really be that excited about my stock or about my product? Like, no, that line is barely even going up. It's almost flat, right? But isn't it the same information? Is this 750? Yeah, I tried my best to make it 750, right? Is this just a little bit higher, like 8? Yeah. Is this 850? Yeah. Is this 950? Yeah. And so it's the same information. It's just that whenever you do a big break in the axis, you really zoom in on things and you make, what happens is you make the change look greater than it really was. This only went up by $2, but it looks like it's, what, almost 4 or 5 times higher than where we started? And so that's how you can mislead somebody with a graph. You can also mislead people the other way. You could, instead of doing something like this, say, for example, if I was in a position where I was trying to hide something from somebody, right? Say the price of my product has actually gone up by a whole bunch, but I didn't want to look like it did. Or say if I was trying to hide, I didn't want, maybe it's like the number of coronavirus patients in my area, right? And maybe I didn't want it to look like there were really that many people who had coronavirus in my area, but really there were. You can also mislead people the other way. When something is really, really bad, but you don't want it to look so bad, like what we could do, instead of counting by normal numbers, right? Maybe I counted by just some insane amount that doesn't even make sense, right? Maybe I count by 500s when I really don't need to count by 500s, right? And so let's say this is like the number of people with coronavirus in my area or in my town, in my county, in my state, in my whatever, right? And most of the numbers are really small. Like most of the numbers are, let's say most of the numbers go, let's just, for example, say it goes, in January there were 2, and then here there were, let's maybe say 20, and then here maybe there were 100, and then maybe here there was 400, right? Wouldn't that be kind of a problem if our county's gone from 2 to 400 people in just a matter of time? But if I did that with a graph like this, look at how well, it wouldn't really be bars, it would be dots. But look at how this would barely even go up at all. It would be, you can do it with bar graphs too, really. This shouldn't be a bar graph, really, it should be a line graph. But do you see how that doesn't really make it look like it's increasing by that much? Was there really a need for me to count by 500s if all my numbers are in between 0 and 400? No, it's stupid to count by 500s, right? There's no need to count by 500s because you don't even have any numbers that high. But that's how people can kind of hide information, and they can make the changes look smaller than they really are, right? This doesn't look like, oh, look, there's hardly any, look how short these bars are. There's not a problem with coronavirus in our area. Well, I don't know. If you've gone from 2 to 400 in just a matter of a couple months, I would maybe be thinking there is a problem. But if someone's trying to hide it from me, they can use some ridiculous scale over here to kind of squish everything down, right? And that doesn't make it look as bad as it would is if we counted by, if we counted by 50s, think about how bad this would have looked if we counted by 50s, right? This thing would have gone up a lot better. So, all right, I'm going to stop right there. I'm going to put some questions on the side. I apologize it's taken me so long today. Got distracted with some other stuff. Feel free to give them a try, and then I will be back on Monday. On Monday and Tuesday next week, we'll kind of do a review thing, and then we'll try the test for this chapter, and then that'll be about it, guys. So thank you so much. Thank you so much. Have a good weekend, and I will catch you all on Monday.